was saying, this is our first introduction into what we call logic. And with logic and reasoning and things, we start to build ourselves into being able to do proofs. Obviously, it's not anything we worry about for the first couple of weeks as we get into this. We probably won't do a single proof until maybe towards the end of next week, and those would be probably set up as straight algebra as we go in. Now, when we get into these things that we deal with what we call logic, is we have to understand how you use reasoning. How do you make an argument? How do you validate what you're saying? And that's where a lot of this comes in. That's new to you guys because you haven't had to do that in a math class before, but you've had to explain, you've had to justify your answers, you've had to use definitions to show how something works. You've done most of this thinking stuff, but you just didn't realize that that's in fact what you were doing. Okay? So what I wanted to do today was go through a couple of very simple definitions and simple examples of how logic and reasoning is done, and some of the terms that we use in a sense in geometry to go forward. All right. It's not really, but it sounds cool. All right. So, for example, when we get into this stuff that's called inductive reasoning, this is something that you guys do almost on a daily basis without really realizing that that's in fact what you are doing. Okay. Do you need paper? Yeah, let me back. Thanks. That's what I was wondering. All right. You're welcome. So, like I said, this is something that you guys have done. You do all the time. It's what we call reasoning that's based on observations. For example, I just happened to look over and notice he's just sitting there staring at me. I said, hey, you, I bet you need paper. Yes. I used my observation to say, hey, he probably needs paper to do some stuff. Yes. And I was right.
You know. I will be lying. I don't write it down.
What's that? Kind of, but it's not just a wild guess. It's a true guess. Yeah, it's in what we call an educated guess. Yeah, and you guys have done that in science. You guys did hypothesis, like what's going to happen. You know, if I let go of these, what's going to happen?
They're going to fall. They're not going to fall.
Oh, you got me there. But they didn't hit the ground. Okay, so I'm going with that. So the idea was you had an idea that gravity was going to take over and it was just going to drop, which is fine. You know, you had an educated guess. You just didn't realize that I had cat-like reflexes.
What do you mean cat-like reflexes?
We had a moment. All right. Or another way of saying it, I don't know, this is kind of like the boring way of saying it. Inductive reasoning is basically looking at several situations to arrive at what's called a conjecture. So this conjecture is what we're going to talk about. This is kind of the newish term. The conjecture, and this is the chapter of geometry that sucks because there's a little bit of extra writing. There's all these definitions and little things that we have to put together, so it takes a little bit of time. The idea of here, what we call this conjecture, the conjecture is your educated guess, if you will. The conjecture is educated guess. All right. And what you're doing here when you're talking about this idea of an educated guess, you're looking at a situation, you're gathering information from what you're looking at, and you're coming up with what you perceive is going on. Okay? Yes, sir?
So people that are really good at grades and they're really good at numbers.
Yes, that's a good way of looking at it. Yeah, exactly. That's a really good way of looking at it. I never thought of that. All right, that's really good. Okay.
Oh.
It's like, what am I not?
You're a mine.
I'm stuck in a box. Terrorists. They put me in a box. I don't know. All right. Conjecture, educated guess. We also do this. Wow, this looks terrible. So we look at patterns. So the pattern here is 3, 9, 27, 81. Yeah, you're figuring out what's the next thing in the pattern. You guys have done that before. You've looked at, yeah, you just multiply it by 3. You're looking at sequences. You're looking at what's occurring within numerical patterns so forth. You're using educated guess to figure out what happened between each one of those to come up with what you think is next. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3 would be?
200 and...
what's 8 times 3? 243, very good.
Who said that took the answers right out of it?
And so on and so on, okay? The idea is you're just figuring out the pattern so you can continue it, okay? You've done this before. You just didn't realize that this is what it was called, okay? Now, this one turned out really bad. It's a circle with a triangle, a circle with a square, a circle with a pentagon. What do you think would be next?
A circle with a hexagon.
Hexagon, right. So you're just adding sides to it. So the next one would be a circle with a hexagon. I'm not even going to try to draw that, but we'll just do this because it's easier. Exactly. Using my resources, my best guess is that it would look kind of like this. How many sides would be after that? What's a 7-sided one? Yeah,
Hexagon,
it's a septagon. There's another name for it too. Did you know that? There's 2 names for it. There's a septagon or a heptagon. Yep. It was one of those, and it depends on what textbook you read or how long ago you learned about it. It's one of those. It's no worries, but we don't worry about polygons now. But the idea here is, again, you're looking at specific patterns to come up with what's next in the sequence. You've done this mathematically. You've done this via images. Yes, sir. Not yet. We will, though. All right. We'll get there.
I thought I knew them all.
Read this. What is something you can come up with after reading that sign?
Someone's gonna. Because they care about the animal when they do that.
Exactly. That's a really good. Every year when I show this picture, that's usually what most people. I always get at least one person to say that they care about the animals more than you. Yes.
They're basically calling you dirty.
No.
Yeah, because they're saying that your food's gonna make them sick.
That might make sense. Why I would say that them eating you
If you fall into
make them
the,
sick.
if you fall into a lion in the lions. But they obviously worry more about the animals than you. I think it's pretty funny. All right, try another one.
You wrote this.
All right.
Very worried about safety.
Very worried about safety. Okay. What can you say about this? What are some things you can come up with here?
That they only dressed him up like that to take pictures of him and send it to him.
A bumbo. A bumbo is just it's a seat that little kids sit in. What can you say about this? What is something you're coming up with here? His parents care about him. Okay, that's a good one. Why do you think they care about him? He's got sunglasses on. All right, what up? So why do you think he's got a floaty on? We're on a boat. Yes. Yeah. Now, what you're doing here is you're coming up with observations. You're looking at the situation, gentlemen. You're looking at the situation And coming up with, well, why is he wearing a life jacket? Oh, they're probably on a boat. Why is he wearing sunglasses? Oh, it's probably really, really sunny. They're protecting his eyes. You know, do you think maybe it's warm out? No.
His skin's like glary, so it kind of looks like yellow.
Yeah, he was a very pasty child. Yes.
Wait, you know him?
He's like.
That's my son. Oh, really?
I just said that. I'm like, is that your kid?
Yeah. Yes, we were. This is Connor. Connor's now 10 and a half, but he was maybe 8 months old or so, something like that, somewhere in that neighborhood. Oh, of course, yeah, he's very pasty. He's very, very, very.
See, so look, I got it right, y'all.
Yeah. All right, what about this? Steve was driving to school when his car just stopped 2 blocks away. Okay, there's one, ran out of gas. What else? I'm not gonna write all this out, it's a waste of time. So he ran out of gas. His what? Brake stopped working.
He's tired. God.
His tire popped. We already got a gas.
His engine blew up.
Now, hold on, I got an idea. What if he was trying to avoid having to pay for parking pass? Did you say that? I didn't hear you. Okay.
There's so many kids that actually do that though.
Oh, I know. But the idea is, you're looking at a situation, is there any one of those that could be right?
Yeah.
Is there any one of those that could be wrong?
No.
Yeah, any one of those could be wrong. All right? So that kind of gets us to the other idea here, is as we're using these logic things, is there something you can take, using what we know about geometry, can we draw a diagram? Can we come up with some sort of an idea with some given information to come up with an educated guess about what's going on here? Yes, sir. I can't hear you. What? Okay. So you're saying given points A, B, and C. AB is 10, BC is 8, AC is 5. So, if you have points A, B, and C, you're given lengths.
It's not a line.
Why is it not a line?
Because A, B, and B, C route to 18.
Okay. Now, does it have to be in order of A, B, and C, though? See, does it say that? And that's the idea. Can you come up with, well, what does this have to become then? A shape, okay, well, let's draw it. So here, if we label this A to B, how long is AB? 10, all right. Now,
Now draw a line at AC.
AC, does it tell me what direction it has to go?
No.
Okay. Well, if I go AC, if I drew AB to 10, AC should be about half of that. See what I'm doing here? Oh. I'm guesstimating about what half of that would look like. Since I gave it scale. You guys know what it means by giving something scale? You've done this when you guys have graphed. Whenever you graph something, if you're not using graph paper, if you're making your XY grid and you go 1, 2, 3, 4, if that was 4 spots over, that would be 4 spots the other way. You try to scale it to be close to make it make sense. Same idea here. Since there's no tick marks, there's no graph paper, no number line, if you will. If I'm saying that this distance is 10, if another distance has to be 5, I should draw it so that it is about half the length. Does that make sense? So that's what we're doing. We're trying to give it some sort of a scale. Now, if I call that AC, and this has to be 5, well, it might have to move a little bit closer towards B, doesn't it? Why would it have to move a little bit closer to B?
Because wouldn't BC be longer than AB?
Yeah, by looking at this image here, this would be longer, which means I need to make sure that, well, I move this here again, try to rotate it. If I bring it up a little bit, to maybe here, And then this length would work for 8, wouldn't it?
Bro, I think I'm messed up. Oh, no, I did it right.
Okay, and that's the idea of, so by moving those points around, there really wasn't a way to show that those guys were collinear. We couldn't show that they were in the same line. But there was a way that we could kind of show that you can make a triangle. All right, that's the idea here. Can we kind of make things work? All right. The other one here is what we call a counterexample. And that's where it came to when we were talking about Steve's car breaking down. In order for any conjecture to show that something's false, you can come up with a counterexample. For one of the ones that you guys were saying about he had a flat tire. Well, if we inspect his car and see his tires aren't flat, there's your counterexample. He does not have a flat tire. So that negates your conjecture. It shows up being false. You can have a counterexample can be anything that disproves what your educated guess is. All right? Anything that disproves it. We do this a lot in more so, maybe tomorrow we'll start it with some of our logic statements. But for example, if I say, if you are 13, then you are a teenager. True or false? True. But can I negate that sentence by saying you could also be 14? All right, let me rephrase this. If you are a teenager, then you are 13. True or false?
It's true. That's not always.
Well, you hear the word teen
Like,
there?
your thumbs are down, but not always.
Right. And that's the idea. Can you come up with a way of disproving that statement? That's what we call a counterexample. So if I say, if you are a teenager, then you are 13, that could be a false statement because you could be 14, 15. Right. You're right, because you can use that counterexample. That counterexample can be anything that disproves what I say.
Wait, but when you're 18, you're now a teenager.
Still a teenager, technically. You're in your teens. Right?
That's crazy.
So that's how this works. Now, you do this a lot with the counterexamples. Okay? You do this a lot. It's a very difficult way to. It's hard to show you guys how this stuff works because you do it all the time without realizing that you're doing this. You can go through statements. You can go through your reasoning when you're working through problems and know how things don't work because you know that it's incorrect. Yes, sir?
It's like starting with wrong.
Yeah.
There you go.
All right. There's a bunch of different ways of looking at this. Okay.
But I just showed that the statistics thing was hard to explain.
Statement. You're going to start to see things written like this. Statements and conjecture. I can give you a statement and a conjecture based off of that statement, and you have to decide if that is going to be true or false. If it is false, I want you to come up with what we call a counterexample. Right? So my statement is x, y, and z are collinear. What does collinear mean again? They're on the same line. Very good. We're going to use a lot of definitions of stuff that we've done. Collinear, supplementary, complementary, things like that. Coplanar, we might have. It's pretty much usually what we start with this type of stuff. So if I say x, y, and z are collinear, and my conjecture, my educated guess then is that x is between y and z. True or false? What does it look like? If they're collinear, they're in the same line, right? All right, so it says x is between y and z. So x between y and z. Does it? So what's your counterexample? Yeah, y could be between x and z. I could say that this is false mean, this is what they're saying because does this statement say anywhere that that is the order? It doesn't. So it doesn't say that the order is there because I can move these around and do that. I can put Y between them. It doesn't state that it has to be that route. Okay, that's where that comes from. That's when you deal with these things in terms of logic and reasoning. All right, that's where this comes with. You look at a statement, and you're like, well, that doesn't really kind of make a whole ton of sense. I wonder if there's a way that I can manipulate it to be false. And that's what you did. You said, no, it doesn't have to be that way. Could I have said that Z is between X and Y? Yeah. All right. Since it doesn't state it, you can't assume it. Okay? We don't want to assume things. All right. This is where the logic comes in. Patterns. Can you recognize stuff?
I'm a pattern.
Everything's got that.
The shirt's a pattern.
Right, see? Those patterns, all of them, they're the same as a pattern.
They're close-ish.
But they got the same color, the same font, the same word, everything.
So let me look at this. Let's see if we can figure this out.
Hey, you talk about how I saw the hallways, and like, every time they should show up. For real, like, at least one of them.
And some are like the first stage.
Like, that's the thing that you're always.
So I'm gonna use this as an explanation and how logic and reasoning works. Now, when you get this, take one part. Okay. And actually pull this up here. Yeah. The other one? Yeah. Sorry, thought I grabbed enough of those. Yeah, and you've done those before. Now, ladies and gentlemen, as you walk through something like this, let me pull up. I'm pretty sure I have this in here. Oops, wrong. Where are my logic puzzles? This is what the card problem?
Yeah.
Okay. So this is that style of problem, like you were just saying, that we use what we call logic and reasoning to come up with a solution to the problem. Now, in this case here, there's a narrative as well as this gridded sheet. Have you guys ever worked with grid sheets before?
Yes.
Okay. What do you have to do with them?
Well,
Listen up here.
you get like some clues and figure out who like
Who did what?
yeah, who did what or who said what for something to
Okay. You guys ever play the game Clue?
yeah.
That's logical. Did you ever see the movie Clue?
Yes.
That's great. Okay. Now the idea behind all this, as you're going through, is you're trying to figure out using logic, reasoning, counterexamples, all of that to decipher what is going on. So, for example, as we read this, spring is in the air, and our 4 garden enthusiasts are eagerly making their plans for their spring planting. Each gardener is planting one large garden plan for vegetables and several small gardens for flowers. This year's planting will include one more vegetable and one more flower than last year's garden had. As it happens, each gardener also plans to break ground on the garden unit on a different day. Use the clues to determine the full name of each gardener, what new veggie and flower will be grown, and which day of the week each person plans to break ground. So the idea here is, the first clue says Mr. Hart did not plan to break ground on Monday. Correct. So I know that Mr. Hart
It's not going on Monday.
Miss,
We have to figure out which one
Correct. So Hart is here for the last name, and we follow through. We know they're not planting on Monday. So I know they're not planting on Monday, and it said the name was Mr., which means what's not their first names? Marge or Sharon. See how this works? All right. See how that goes? Now, from there it says Patrick's last name is not Lamb. So Patrick is not Lamb.
Wait, what?
I still got confused, you know?
All right.
Marge didn't plant seeds or
Peas.
Oh,
So the next one.
Wow.
Marge. Marge is here. She did not plant peas. So I'm going to put an X in the peas. She did not plant peas. The gardener, whose first name is not Patrick, breaking ground on Thursday, is planting corn and daffodils. So not Patrick, so it could be either Marge, Sharon, or Toby. So if it's not Patrick, Patrick is not, Patrick means when is he not breaking ground? Thursday. See how that goes? You're using that information that's thrown out there. They say that Patrick, or the gardener whose first name is not Patrick, breaking ground on Thursday. So not Patrick is not on Thursday.
I'm still on.
Anyone who's not Patrick?
Okay. So that means whoever does break ground on Thursday, and we'll have to come back to this, that person is, whoever does corn and daffodils is on Thursday. So we know that somehow, some way, whoever gets corn and daffodils, these two are together. And that also has to go with Thursday. Okay? Does that make sense, how we're reading through that? All right. Toby Garrett. Oh, we know a name now. Toby Garrett. So Toby, let's see if I can get it this way. Toby Garrett.
So that makes sense. That's what we can't do.
Ding, 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 ding. So we know the guy's name is Toby Garrett. The guy's name is Toby Garrett, which means nobody else.
Toby here.
So it's Adler.
I crossed all of those off because the name is Toby Garrett. We know his full name, which means then, what is Patrick? It's either going to be, we don't know, it's either going to be Patrick Adler or Patrick Hart,
That's hard.
or it's going to be,
That money on it.
all right, so we're starting to break those down. He plans to break ground on Friday, so Toby Garrett, Friday, which means nobody else can break on Friday, and nobody else, he's not going to go on any of the other days. We're backing out what he can't do versus what he can do. Yes, sir? Oh, yeah, I'm sorry. I might have missed it. Yeah, so it has to be Patrick Hart. I'm sorry. Thank you. So then they cross off here. I think when I looked over it real quick, I thought the X was over something else. When I looked. You were right. I'm sorry. I just missed it when I looked at it so fast.
Hey, man. Why did you bet?
I'm sorry, what? How did I cross off out? Because when we were at, let me back this out real quick. When you're looking at this one here, Sam, see how everybody is already crossed off here except for the one named at Hart? That means Patrick has to be Hart, which means what can't Patrick be then? He can't be here. Because all three of these were crossed off underneath Hart, so it means that he has to be that person. Okay? Something else about Garrett, he's not planting corns or azaleas. So he's no corn, no azalea, which means if he's not corn, he's also not daffodils, and he's also not Thursday. And we already have, did I put on Garrett? Oh, I clicked on the wrong person there. I'm sorry. I was looking at. Sorry. And that was Toby. I was just working off of the other one. So Toby is not corn or azaleas, which means if you're not corn, you're also not daffodils. And we already have him not on Thursday, so that's good.
Whoa! All these X's on my picture.
The gardener planting on roses is not planting on Thursday. Sharon Adler is planting peas. Let's do Sharon Adler first. So Sharon Adler, so here's Sharon Adler, which means Marge is not Adler, it's Marge Lamb. So we got the people. Okay. It said she's planting peas, which means if she's planting peas, nobody else is. Oops. She is planting peas, but she is not planting daffodils. We'll go back to that here in a second. And she's not daffodils, which means she's not planting corn. Very good. Which also means she's not on Thursday. Very good. See how that falls into place now by marking up what goes where? It is. It is. So that means who's planting on Thursday? March. See that? Which means she's planting daffodils and corn. Very good.
Which means that Patrick isn't planting corn or daffodils.
See, and all I did there is I crossed off the other possibles that deal with March. Okay. Now, question came up with, why is it also written downward as well? Well, it's so that way you can read both directions. So now that we've filled out a ton off of the top four, going left and right, let's mirror it going downward as well.
Oh!
Okay? So we know that Marge, if we read this, Marge is Thursday, so Marge Adler, I'm sorry, Marge Lamb is Thursday. See where I'm going? See how I'm doing that?
Yeah.
So we know that we went by first names this way, last names this way. She did corn. She did daffodils. And Thursday. So we have her 4 spots going downward, which means everything else in that lamb category is an X. I do the same thing with Hart. Patrick Hart. Hart was here. We don't know anything else except that he is not corn. He is not peas. He is not daffodils. He is not azaleas. Thank you. Oh no, we don't know about azaleas yet, because that's gonna be one of those two. And he's not Thursday, not Friday. Which means he has to be Saturday. Everybody see that? Which makes Adler. Yep. So now Patrick then was Saturday. And just by reading these things through, which makes them Monday. So now we come back over to the other way and match them up. Sharon was Monday, and then what's left from Patrick? I'm sorry, Hart. Nope, he was here. Toby Garrett is on Friday. Okay. All we're using reasoning and logic going back and forth off of these. Who? Adler, Marge, she's corn. Corn, daffodils, and Thursday. So Marge. No, Marge Lamb, I'm sorry. Adler is Sharon, so Sharon is peas. So that'd be peas would be here. And then we need. Do we have beans or anything yet? Nope, we're not there. We have the one. All right, next sentence. Whoever's, we do the Friday one yet? Yeah, we did. Friday is not beans. So Friday, we crossed off beans. Friday, cross off beans. Which means, what is he doing then? See how this means that he has to be doing carrots?
Oh, yeah.
By following it, going back and forth like that, he's got to be on carrots. Yep. Then you can bring that back the other way. So beans was
Lamb. No.
heart.
Yeah.
So Patrick is your beans. And then this was a no-no here, which means Toby was that one, which it was. The gardener planting carrots will break ground after the gardener plants azaleas, but before the gardener plants tulips and beans. So who's planting carrots? That is Toby. So Toby is planting on Friday. He's breaking ground after whoever plants azaleas, so that's either of those two. But before the person does beans. So that should be Patrick. So it's after azaleas, before tulip and beans. So tulip and beans, that means Patrick, since he's beans, he has to be tulips. Because that's the only person that they're before. See that? Thursday's the only one, I'm sorry, Friday's the only one day before the Saturday, so it has to be that person to do the tulips. Which means not here, which means this person is this. And that.
You're right.
And then that basically falls into everything else.
Now we're gonna write our those, right?
Yeah. And that's just a matter of matching things through. What's weird with these things, guys, is that you can make a silly mistake halfway through, but you want to remind yourself that you're just following the pattern. You're trying to use the logic and reasoning to make it go. Right? That's what we're trying to accomplish today. Can we use the logic portion of this to figure out who did what? We're basically just looking at a puzzle. All right, so let's see if we can fill in the rest here. So, Marge, lamb, corn, daffodils, Thursday. Marge, lamb, Thursday, daffodils, corn. Good. Patrick, heart, beans, tulips. Heart, tulips, beans. Good. Cross off those. From there we had, what was Patrick? He was also Saturday. Yeah, Saturday. Sharon Adler, peas, azaleas, peas, good. So they're not here, which means these are roses. And then, who was on, fill in the middle parts here? So whoever was Monday had beans, so Monday, beans here. Thursday was corn. Thursday, corn. Friday was carrots. Gets us those. Azaleas and azaleas and peas. Azaleas and peas. Daffodils and corn. Tulips, beans, beans. Bless you. Yeah, every once in a while. And that's the part. I mean, usually by the time you get the outer edge, everything else is just replicated. And then, let's see, we've got Monday, azaleas. Who's on Monday? Monday, azaleas. Thursday, daffodils. Friday is roses. Oh, another diagonal. And Saturday is our tulips. Yeah, these are pretty cool. I like these a lot. I like these a lot.
I finished.
Yes, sir.
So Patrick planting beans on Saturday. Patrick's planting beans on Saturday, yes. Okay, so what does that mean in that middle box right there? The bottom left would be a circle. Yes, Patrick is planting beans on Saturday.
Oh, did I flip it? I did. I wrote it peas. Yeah. It should be this, right?
That you did it. I just
Should be that. I think, yeah, Saturday beans. Yes, thank you. I think I missed it when I read beans and peas is the same word. Yeah, I just read it as the same word. I mean, as you go through this, you can get away with just doing the top L part as you go through. But I want you guys to try tonight. I've got 2 of these. Don't give me any of that.
They're not as big as
I'm the best at
All right. Now, as you do these here, it is much easier. Tear the top sheet off as you're looking at the grid sheet to go through. Okay? Yeah. You should have most of those stuff. No. No. That's how you find the solution. Honestly, what would happen is if this is done, then you can say, oh, first name is Marge Lamb, her veggie was corn, daffodils on Thursday. That's what you're reading. Okay? What's that? I don't know, I've got a whole bunch, I got a ton of these things, and these are just a couple ones that I printed out just to give you guys a shot.